In this video, I will talk about the advection equation. In these initial lectures, I'm just giving you an overview of the equations that will be used in this course. In future, we will talk about, we will derive actually these equations in detail. So let me just discuss this equation first. The name of this equation is advection equation, or sometime it is called convection equation as well. In the previous video, you saw that we have written a system of first order equations. It is similar to the equation like this: ax is equal to b, system of equation. Similarly, when we write a system of first order equation, we write like this in vector form. This is a vector equation. If we take q vector as a scalar quantity, q is a scalar quantity, and take the coefficient a as a constant u bar, then such equation is called advection equation, which is a special case of this system of partial differential equations. Remember that this q can be anything. It can be a momentum, it can be energy, so on. This u bar is the velocity. We cannot say a matrix is equal to vector. It is just a scalar quantity. U bar is a scalar quantity. Some people, q is also a scalar, not a scalar in the sense it is a number, it is a function of x and t, but it is just single function. Now, if I define such function, then that will be r cross r is equal to, since we are getting a scalar quantity, then this is called, the output will be a real number r as well. And such function is written like this: x of t is equal to q, which is a number. And such function is also called real valued function. So let me just explain it further. If, for example, q is a concentration, c, then that equation will be partial c by partial t plus u bar partial c by partial x is equal to 0. It means that this concentration of some contaminant, has a speed u, which is transported. For example, if we have a cylinder and there is some contaminant like this, then the concentration of this contaminant is denoted by c. And if this contaminant has a speed u bar, then simply this contaminant transport from one place to another with speed u, bar in the next location. It means that the solution of such equation is written by some quantity which I explain later, but let me just give you another example. If, for example, here Q is density rho, partial rho by partial T plus U bar partial Q by partial X is equal to 0. So I'm sorry, rho. If the density of some fluid is transported from one place to another, then we use this equation. If, for example, Q is the pressure, partial P by partial T, U bar partial P by partial X is equal to 0, then the pressure, for example, if there is some pressure over here, that pressure will be transported from this place to another with some velocity u bar. That is the logic of advection equation. This has some consequence in Navier-Stokes equation, and we will talk about that later on, since these are the introductory lectures. So, if something is transported from one place to another, it means that it will not change its concentration, its pressure, or its velocity, its, for example, density. Suppose we have X and on the y-axis we have Q. Initially, at some initial time, we have this profile. And this profile is at t is equal to 0. It means that Qx0 is equal to Q naught. After some time, this quantity Q will be transported towards the right. So there will not be any change. There will not be any change in the height of this quantity Q. The solution of such system is written as, since Q naught will just move towards right or left, it depends on the speed. If U bar is greater than 0, then the wave is moving from left to right. Otherwise, it is moving from right to left. So in this case, the solution of general equation will be Q is equal to Q tilde X minus U bar T. That will be the solution of this equation. Okay, let me just show you the graph. On the x-axis, you can see that this is X, and on the y-axis, we have U. For example, this is some velocity, and we have initial value. Initial value is, this is initial value, and after some time we have another profile that is just moved toward right. Theoretically, the initial profile should move towards right without changing the height, and it should remain the same. It should not look like this, for example, like this. Then it is not good. This is not advection equation. So advection equation just transport the initial concentration or initial density from one place to another without breaking down. Thank you for watching.